All right, folks, so what we have here is a box from Retevis. If you take a look at this sticker on here, you can see that it is the RA79. Its max RF power is less than 5 watts. Its input is 5 volts at 1 amp. And if you take a look at the frequencies, it's 144 through 148 megahertz, or the 2-meter band, and then the 70 centimeter band at 420 through 450 megahertz. Now, it can receive on frequencies other than these, so this would just be your transmit frequencies. And there's some other information on here, like made in China, but that's not a big deal for us. So what I want to do is take a quick look at this, but before I do, I want to say that I was contacted by Retevis and asked if I would do a video review of this particular product. Now, if you're the type of person that is easily triggered by sponsored content on YouTube, I would suggest you go watch some cat videos. Okay, so let's take a quick look and see what's in here. We got an instruction manual. We got a programming cable, which is fantastic. I don't know if they all come with that or if they just sent that one to me, but we'll take a look and see. We have a USB wall adapter. We'll put that over there. We have our antenna. We have a charging cradle that has a USB input on it, so that's pretty handy. And if we take a look over here, we've got a pocket clip, and then we have the lanyard. Now, I never use these lanyards. I know some people love them, but I don't use them, so that's going to go away. And let's take a look and see. We have the radio itself. This is where your pocket clip snaps in. Here's our battery. We'll look at specs on that. Here's the front of the radio. I like this big old button to make it easy to turn on and actuate. And then it has this button, or this knob guard on here, so you don't accidentally bump it. Alrighty. What I want to do now is I want to get this set up and start playing with it. Okay, so I turned the radio on, and this is what I have on the display. Now, if I activate the menu, it gets really bright and gets washed out on the screen. So what I want to do is I want to turn off the backlit display. So let me do that real quick, and I understand completely that you're not going to be able to see this. And go in the menu, and I believe it's called ABR. There it is, and I'm going to hit menu, and then I'm going to turn this off. All right, there you can see the ABR, and you can see that it is off. So let me get out of the menu. Oh, let's go hit the exit button, and we're back at our home screen. So this thing comes with, let me zoom in a little bit more. So this thing comes with some channels programmed in it, and you can see those here. And from what I can tell, they appear to be ham frequencies, but I have no idea. I believe you can program this thing with some computer software, potentially even chirp, so you could see what channels are programmed in here or update those. It has a keypad and it feels pretty good. What I was looking for is if there is a charging port on the side of this, and I don't see one. I was curious if you could just charge this directly. And there is a USB plug down here. And it does have a USB-C plug on there. And we just happen to have a USB-C plug right here. And now we have this blue light up here, which I assume means charging. And then you can see right here, it's showing that it's plugged in the upper right-hand corner. So that's pretty handy. I like that. That would be a very helpful thing. Okay, let's just see it boot up real quick. You get a welcome screen and then the Baofeng lady inside. Let's go back into menu. So here's our squelch setting. We can set our step. We can change our text, our transmission power. And I believe it is 1, 2.5, and 5. There should be 3 settings here. And we got high, medium, and low. We're just going to leave this on. How about we just go with medium for right now? And then I want to hit menu, confirm it, and now I exit out. Let's go back into our menu. And it said cancel when we exit out, but it still says mid, so that's good. You can set your receive DCS tone, your CTCS tone, your transmit DCS and CTCS tone. We have those all for right now. You set offsets. You can go wide or narrow in terms of your transmission. So wide is 25 kilohertz and 12.5 for narrow. Oh, I didn't mean to do that. Let's get back in the menu. You can set memory channels. You can save them. You can enable Vox. It looks like it's just got the standard, I think TDRs where you, let's hit menu and see what we have here. This would be dual standby. And then this would be setting your primary. We're going to leave our primary on A, and we're going to leave dual standby on. So let's just exit out of there. You have some weather, emergency weather reception. I think this has 10 weather channels on it. We're going to leave the beep on. We have a timeout timer. The voice is set for English. Let's see if we have anything else we want to talk about here. You can set your mic gain. We're going to leave all this default for our testing. And I believe these are scan lists that you can set. Multiple scan lists. We don't have anything programmed. So it's pretty cool, and it looks like you can do a lot of settings from this. What I want to do now is I want to go outside. I'm going to turn on a SDR, and we're going to see what this thing looks like from a spectrum standpoint when it's transmitting. We're also going to hook it up to a spectrum analyzer, but people like to see transmission and receive tests. So let's go ahead and do those now. Okay, real quick, this took me a minute to figure out. If you take a look at the screen here, you can see that it is memory mode. And so the top we have memory 16. If I take and I push this frequency button and the number 3, I'm sorry, function button and the number 3, you can see that it just switched to frequency mode. And then I can type in a frequency like 14650. And we can switch back to memory mode. They call it channel mode. Now we're back into frequency mode. Okay, now let's test the transmission. Testing 1, 2, testing 1, 2. Medium power from the Retevis. Testing 1, 2. Testing 1, 2. Testing 1, 2. Testing 1, 2. At 5 watts. Okay, so now what we're going to do is a power test, and we're going to see what the power output on this radio is. So here we have the Retevis, and it is connected through the NSA RS40 SWR and power meter, which goes into this MFJ dummy load. And we're set for the 15 watt scale, and our function is set to power. So I'm going to go ahead and I'm going to key up on 14652, and then you should be able to see right here is an L, and it stands for low power, which I believe is supposed to be 1 watt. And you can see it's just over 1 watt. So what I'm going to do now is I'm going to hit menu, and then I'm going to hit menu again, and we're going to set it to mid. Now what I don't like is when I hit exit, it says cancel, but it didn't cancel it. So I'm going to go ahead and key this up. It's supposed to be about 2.5 watts, and we are just over 2 watts. So I'm going to say that that is okay. So now I'm going to go back into the menu, and then I'm going to hit this again, and I'm going to go to high, and then I'm going to confirm, and then I'm going to hit exit where it says cancel, which I don't like, and I'm going to key up, and it looks like we're at about 4 watts. Let's go ahead and test on the 70 centimeter band.
44600.
All right, this time we're going to work backwards because we're already set on high, and we are right at 5 watts. Let's go into menu, and let's go into power. We are at mid, confirmed, key up, and it looks like about 3 watts right there. So let's go back into menu, and let's go back into power. Low, confirm, exit, go ahead and key up, and it's just over 1. We're going to go ahead and we're going to call that a pass. Okay, let's take a quick look at the Retevis website, and we can see a couple of different things. You can buy this off of Retevis. I'll have this link below, or you can pick it up off of Amazon, and I'll have that link below. Also with some bundles where you can get more than one of these. If you take a look, it's $32.99. You can get 1 pack, 2 packs, and 10 packs. And let's go ahead and scroll down because there's a couple of different things that I wanted to point out. Here it says the radio is 50 to 600 megahertz for receive, aviation band, and it also says 5-watt ham radio, free shipping to the United States. It talks a little bit about airband being a receive only, so you can't transmit on that. Also, another thing to pay attention to is this is an AM modulation for airband. And if you come down here, you can see multi-band receiving. I'm just going to highlight that real quick so you can see it. And it shows the different bands and the designation. So frequency set 1 is 50 to 76. Frequency set 2 is 108 to 135 RX only. Then we have this one right here. Frequency 3 is 136 to 173.9750. That's TX and RX. Then again, we have RX only on 174 through 349, RX only on 350 through 399. Then down here on F6, we have 400 through 469.9750, TX and RX both. I think this said something differently on the box. Then we have another RX band from 470 to 600, and FM radio is from 76 to 108 megahertz. Let's scroll down. This talks about easy pairing. So if you have two of these, so here it talks a little bit about easy pairing, and this is to detect frequencies in CT/CSS for two-way radios. So this means that it will actually scan those and pick up signals that you might be looking for. Another thing is that you can clone these over the air from one radio to another, which is a pretty handy feature that we can't test because we only have one of these radios. Let's scroll down, and the other thing we covered a little bit about the USB-C charging, so we're not going to go into that. The battery is 1400 milliamps, and I think we talked a little bit about 10 weather channels. Has a built-in flashlight for all the whackers out there, and that'll save you when times are tough. It says long-range communication. I don't know exactly what that means. But I wanted to come down here because I know a lot of folks are going to be saying that, hey, this is just a rebadged Quanshang UVK5. So they do address this, and they say in their FAQ question, what is the difference between the RA79 and the Quanshang UVK5? And the answer is almost the same. Don't worry about shopping on Retevis. I do believe that these are the exact same radio. And I think that's going to cover it. If you wanted to, I did want to show this. What's in the box? You get the ham radio, you get the charger, the battery, the user manual, belt clip, antenna, adapter, and lanyard. So it would appear that the programming cable was stuck in that box because I'm doing a review. So you may need to pick up a programming cable, but it is the standard cable that we use with the Kenwood K-type connector that you see on almost all of the radios that are coming out of China. Okay, what we're going to do now is we're going to test the spectral purity of this by looking for harmonics or spurious emissions. And so we do this by taking our radio and connecting it to a 40 dB attenuator that goes right into our Tiny SA Ultra. What I'm going to do now is I'm going to connect the Tiny SA Ultra up to my computer to make the screen a little bit easier to see. So we're going to come back when we do that. We are going to test the spectral purity on 146/500 at low, medium, and high power. The reason that we don't test the spectral purity on the 70 centimeter band is there's no FCC regulation for that. So let's go ahead and get started. Okay, we've got the Tiny SA connected to our computer, and you should be able to see it right about, and I always get that wrong, right about there. So what I'm going to do is I'm going to open up our menu, and I'm going to go down to the measure setting, and I'm going to pick that, and I'm going to pick harmonic. When I do that, it asks me for a frequency, and we're doing 146.500 megahertz. And so now what it's doing is it's configuring our Tiny SA, and what you can see now way up in the corner is a data table that will show our primary marker on our fundamental frequency when we key it up. Let me just take a quick look at this radio because I forgot to check it, and we are set to medium power, and we're going to start this on low. So let me go ahead and do this. And now we are set to low. All right, and as I mentioned, we are doing this on 146520, but we also need to go back to our tiny SA, and we need to go to level, and then we want to set our external gain to negative 40 dB because we have an attenuator in line. So now the tiny SA is calculating that. And one of the things that we want to do is we want to go back to, I believe it was under level, and it is not. I believe it is under display. Draw a line, and we're going to go to negative 16.02 dBm. And then now we should get a blue line that goes across the screen. So one of the things that we need to do when we do this test is any other transmissions, harmonics or spurious emissions, other than our fundamental frequency, need to be 40 dB below the peak of the fundamental. They also need to be below that blue line, negative 16.02 dBm. So what we're going to do now is we're going to key up our radio, and we're going to give it a second to sort itself out. And we are doing a 4-sweep average, I believe, and so we're starting to get some data now. Let's give it a few seconds. Okay, so it should be sorted out by now, and what we can see is that we have our fundamental and then 2 harmonics. When we take a look at this, both of those harmonics are more than 4 dB down, which is a good thing. And if we were at 31.6 minus 47.4, I believe that is going to put us right on the line of the 16.02. So let's do some quick math and figure that out. Hold on one second. Okay, so I just did the math where I took 31.7 minus 47.5 is what it was at the time. And that doesn't get us where we need to be. That's 15.08. That's really, really close to the 16.02. I'm sorry, it's 15.8. That's really, really close to where we need to be, and it could be within the specification of tolerance. So for the sake of the setup and everything, I'm going to say that that's a pass, but it's really, really razor thin, and it's right on the line. What we want to do now is that we're going to let up on our keypad, and we are going to set this to medium power. Okay, now we are at our medium power, and we are going to key up again, and we're going to see what we see. Okay, so we just have everything about sorted out, and we take a look at this. We can see our fundamental at marker number 1 is around 34 dBms, about what we expected. When I take a look at this, the second peak or the first fundamental, sometimes I call it the second fundamental. But so anyhow, with number 2, what we see is that it is below the 40 dB threshold, but it is above the negative 16.02. And that would mean, and it is over by enough that I would consider that a fail. And that would mean that using this on the 2-meter band for medium power appears to be against the FCC rules. Let's try it on high power and see what we get. Okay, so now we're set up for high power, so let's go ahead and key up, and we'll let the tiny SA sort itself out and get the measurements settled. Okay, and I think that we've got everything settled down. And what we can see is marker number 1 is around 36.2 dBm. Now the frequency there says 14.6.8, and we're doing this at 14.6.5. You lose some of your accuracy or your granularity when you have less data points on a large sweep like this. Our sweep is spanning 1.3 gigahertz. If we were to shrink our span down, that frequency would be spot on. And what we're seeing there is the second marker is negative 50 below the primary, which is a good thing. But again, it's above that negative 16.02 dBm line, and that would make this something you shouldn't use, according to the FCC, on the 2-meter band. Now, whether you choose to do that's not on me, that's on you, and I wish you good luck and hope you don't get caught if you do that. Okay, apologies for this being a little dark, but it's because of the brightness of the Tiny SA. So one of the other tests that we're going to do is called a SINAD test, and it's the signal to noise and distortion test. And it measures how well your radio can hear. So after I show you the setup, what we're going to do is we're going to take a look at the manual and what it says for SINAD testing, and then we're going to do a couple of SINAD testing. This is very similar to the test that we do for spectral purity in that we have our radio connected through an attenuator to a Tiny SA. This time we have the Tiny SA set up as a signal generator and not as a spectrum analyzer. So we're using the low output, which is this port right here. Our frequency is set for 146,500 and the level is negative 123 dBm, which is supposed to give this 12 dB of signal on here. So that's how we would measure SINAD. I don't know if 123 is the magic number or not, but we're going to test it. That is what is documented. So for modulation, we're going to use FM modulation and a 100 hertz tone. We're not using a sweep, so it's going to be off, and we're not going to start the sweep. Down here, we've adjusted external gain to negative 40 dB to count for our negative 40 dB attenuator. And our output is going to be a sinusoidal wave. So let's go ahead and take a look at the specs from the manufacturer, and then we'll go ahead and run this test. Okay, we're using the speaker output from the radio to go through a cable into a sound card on my computer. And we're running this software. It's called Contact SINAD 1.20. And what we want to do here is we want our SINAD meter to get up to a 12 dB signal. What it uses is a notch filter to notch out the 1000 hertz tone or 1 kilohertz tone that we inject into the radio. And then what it does is it does a measure of the sound level, compares it to the sound and distortion, and gives us our score. So what I'm going to do now is at a negative 123 dBm is I'm going to go ahead and I'm going to turn this on. Now when this turns on, you do see some activity taking place over on the SINAD meter. And this is a relatively low signal, but you can see our dB rating is somewhere around 15. Now it just went down to 14, and it's fluctuating between some 14 something and 16 something. But I'm going to consider this about 15 dB of SINAD, and we want the number to be at 12. So what this is telling us is that our signal is too strong. So what I'm going to do is I'm going to lower it by 1 dB, and that is negative 124 dB. And now you can see our signal is fluctuating between 12 and 14, mostly hanging around in the 13 mark. So let's go down one more. And so this is 125, and then you can see that it is not meeting our mark. So even though at 120, let's go back up 124, we are a little high at around 13. Let's see if we can set this to 124.5. Set negative 124.5 times 1. And that looks to be around our 12 dB, and they're just cut out. So let's just go back to negative 124. And I think we're going to say that this is somewhere around 124. Now the rating in the manual, as we saw, was 123. So that means that this passed the SINAD test for the 2 meter band. Let's go ahead and check it for the 70 centimeter band. Okay, we've adjusted our frequency to 446, and that is what we have our radio set to. So again, this one says it's 123, so let's just go ahead and add a dB and turn this thing on, and we are not seeing anything. So let's go up another dB, and we're not seeing anything. So when I jump up to 121, we're seeing over our 12 dB score. So let's go ahead and drop this back down to 122. Drop it down to 123. So it's somewhere between 122 and 123. There we go. 122, drop it 1 to 123, and it dies. So it's somewhere between 122 and 123. Again, the rating that we saw is 123. So I'm going to say that this one doesn't quite meet the mark, but it's close enough. Now, one of the things that everybody says is that this works really well for AM receive. Now, this one, the score is 10 dB. Signal to noise ratio. It's not a SINAD reading. So let's go ahead and configure everything for that particular test, and we're going to test at 120 megahertz. Okay, we're set up. We have the radio set for 120 megahertz, and you can see that over here on the spectrum analyzer. One thing I want to point out is we've changed the modulation to a 1 kilohertz tone, or 1000 hertz. We set our modulation at AM this time with an 80% depth of deviation, which is the standard for a test like this. You can see that we're on, and then our level is set to -123, which is where it was for the FM test that we did. Now, the book says that this would be at -113. So if I turn it up, you can see that our dB scale is reading around 36, which is way high because it's rated as 10 dB for AM. So what we're going to do is we're going to drop it 10, which means that we're already exceeding the specification by quite a bit. And we have 27, 28. Again, that number is supposed to be around 10. So let's go ahead and drop it another 10. So now we're at 133, and you can see that we're really low. So we're just going to continue to add ones. So right now we are at 130 dBm. Let's keep on adding ones. And that is at 127 dBm, and it is exceeding the rating. So if I drop it down to 128, we're still exceeding. Let's drop it to 129. So it's somewhere between 128 and 129 to get our score of 10 dB, and that's pretty good. So I'm impressed by that. Okay, so we have the radio set up to our Regal oscilloscope. We have a frequency counter highlighted there. The radio is set to 146.5 megahertz. We're set on medium power, and what we're going to do is transmit a carrier signal into the oscilloscope, and we're going to look for a clean sinusoidal wave. And that is one of the tests that we do here. Not all radios have a clean sinusoidal wave, so we're curious about this one. So when I key up, you can see that's exactly what we got, a pretty clean sinusoidal wave. So we're happy here, and our frequency counter is spot on at 146.5.50. So we're going to go ahead and we're going to call that a pass. Okay, and I think that that's going to wrap up all the tests that we're going to do on this video. Now, there's other videos where folks show programming this with software, and we might show programming it with the factory software at Chirp. I just don't know. I do want to say that I'm overall reasonably impressed with the receive capability of this radio. I do want to mention that, however, transmitting, it does appear to be a little bit dirty on that second harmonic. The low power is questionable, but on medium and high, it definitely didn't pass. So that's something to consider if you choose to buy a radio like this. That's your choice, not mine. Overall, it performed pretty well from a power test standpoint, from a SINAD test standpoint, and when we took a look at the carrier signal. And the audio doesn't sound too bad on it either. So with that, I'm going to say thanks for watching, everybody. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below. And I would like to say thanks to Retevis for sending me this radio for my consideration.